Thank you, everyone, joining us for lunchtime lecture. We're joined by Kelly Doran today. We're doing this virtually, but I want to respectfully recognize that we're where we are, and Kelly has offered to read the official land acknowledgement text in a minute. But I will point to the screen with the land acknowledgement aspect of this conduct. Everything that we do really stems from that acknowledgement for sure. I want to introduce our speaker today. Kelly Alvarez Doran is a senior principal at Mass Design Group. Some of you know him. He's a graduate of ED program at University of Manitoba, Environmental Design program. And he studied at University of Toronto, master's program. And he's been since with Mass Group working on award-winning projects in Rwanda and Kenya, some of which he will, I'm sure, refer to. He's a recipient of Canada Council of Prix de Rome for Emerging Practitioner, and he's a visiting professor at University of Toronto and has held teaching positions in Bartlett and Harvard and University of Waterloo as well. I'm so excited to have him today. I'm sure he will cover a lot of grounds today, and it's only a beginning of your return, I would say, Kelly. So with that, off to you.
Right on. Jay, thanks for having me back in the virtual Russell building here. I was talking to Aaron earlier. Did everybody get shipped a little bowl of vegan chili to have at home while we do this? But I'd like to start off with the land acknowledgement that the University of Manitoba campuses are located on the original lands of the Anishinaabe, Cree, Oji-Cree, Dakota, and Dene peoples, and on the homeland of the Métis Nation. We respect these treaties that were made on these territories. We acknowledge the harms and mistakes of the past, and we dedicate ourselves to move forward in partnership with Indigenous communities in a spirit of reconciliation and collaboration. Thank you for spending your lunchtime with me or your dinner, depending on what part of the world you're in right now. And I'm going to speak, to our work, to Mass Design Group's work, and to some of the research that I've been leading at the University of Toronto as well this year. Let me just move forward to the slide here. Mass Design Group stands for a model of architecture serving society. We're a group of 120 architects, landscape architects, engineers, writers, filmmakers, researchers, coming from a wide variety of countries. This slide's a little outdated. I think it's actually around 25 right now across the globe. We were started over a decade ago around this premise that architecture is never neutral. It is inherently can either hurt or heal. And more recently, we've been thinking about architecture and its role in climate. And as you'll see, much of this talk is going to be focused around it. That also, architecture is never sustainable, and I don't think it can pretend to be. It can't. Sustainable is a kind of neutrality. So we can either choose to be climate negative or positive. And I think what I would argue today is we really need to change the way we think and speak about the role that architecture has as it relates to climate change. The document that came out now, 2.5 years ago, which really turned my head, was this by the IPCC saying, hey guys, by 2030, if we're going to meet the 2050 targets of carbon zero, in this decade, the one we're in right now, with 8.5 years, we have to have the emissions we had in 2018. And that is really, I think, a kind of simple question with profound results when you ask yourself of it. How do we have the footprint of everything we're doing right now with the 8.5 years we have left? And importantly for architects, engineers, builders, people in the construction industry, we have to actually understand what we're having. And as you'll see, annual emissions globally, 40% are attributed to buildings. 28% the building's operations, the heating, the cooling, the lighting. This pink pie is really where certainly my education revolved around when talking about sustainability. This other blue piece of the pie, I think, has kind of been absent in our thinking. This new building construction, the embodied carbon of our building, has really not been paid attention to. And it's a compounding problem because every year this 12%, this 11% piece of pie is kicked up into the pink pie. So all of these new buildings that we're out there celebrating and seeing in magazines are only aggregating into the bigger problem, and at a rate where we are adding a New York City to Earth every month, all 5 boroughs. And it is the urgent problem, arguably, as well. Because embodied carbon is upfront and spent, it's where our agency exists, it's also the thing that's going to be the biggest footprint in the decade we're currently in. So if you're working on a new project, this really needs to be front and center of your view of where we can make emissions reductions. Now, in the food sector, this is the oat milk I drink every morning. It's really interesting to see like what's happening, around food and how that industry has come to terms with a lot of this, where I can say, oh, here's how my oat milk relates to cow's milk from an embodied carbon, or from the embodied carbon of milk perspective, and where along the supply chain those emissions lie. I mean, it's largely farts. It's the methane from a cow on the farm. That's the part of it, right? It's not really in the packaging and transport. On the flip side, in architecture, we don't really have a good view of that. We're actually really under-equipped to even begin to understand that. And instead, we're faced with this kind of thing that would come out to you through a mailer from, you name your provincial association, they're all would send you an email about, hey, you want to meet the 2030 targets, use this, right? Rooted in sustainable technology, this styrofoam brand facilitates a future of innovation in building and construction. So this is the face of sustainability in construction. Our focus, I would argue, over the last couple of decades has really been around operational water and energy use. This is where sustainability lives, and I think it's time for us to broaden that out and take a more holistic view of what a building's life cycle is. And so here you can see, the upfront cradle to gate emissions of a project in a 60-year time span is actually equivalent or greater than those of the operational part. And as an architect, that's where your maximum agency is in the specification of the construction, not ultimately how the end user uses the building. Reflecting on this, looking at a cottage that I did for my family a few years ago up in Ontario, I was in Dwell, and it was spoken about in kind of terms of sustainability, that the cottage is highly sustainable, the tightly insulated structure, et cetera, and designed for things like passive ventilation and all the things Leon Fedenu taught me I should be doing in my undergrad. It faces south, this thing's going to function quite well. It does it with a kind of dirty little secret under its fingernails. And, part of it is all the stuff in this photo doesn't come from Canada. All of these finishes are coming from some other part of the world, right? The second part of it is like, well, this wood frame cottage in the middle of the Canadian wilderness, it's off grid, doing a lot of things, the right way. But I was really beginning to be curious, like, well, at what cost? Like, what is the embodied carbon of this cottage? So kind of took it apart and went back to the drawings a few years later and built myself a pretty detailed little model of it to understand, okay, what's in it? What does my building weigh? As someone was famously asked at one point. And I can tell you what this building weighs and where the weight is. And unfortunately, the decisions I made, 7 years ago, many of them I've come to regret. This cottage represents 92 tons of CO2e. This is the equivalent of me driving a car on this earth for 92 years. That is the footprint of this cottage, right? And where is that footprint? Well, only 10% of it is in the wood frame. And so this is the upfront. This does not account for any sequestration. This is simply, what was expended to cut that tree, mill it, and bring it to site. 65% of it was in this crawl space, this concrete crawl space, which nothing is in except for maybe a case of wine. And is the kind of, I would say, the de facto foundation of most buildings in Canada. It's something I'd like to talk about. You'll see later on. And 58% of this building is petrochemical, is materials derived from oil and gas here. So XPS insulation and bitumen roofing, two materials that I'm sure you're all very, very familiar with through practice. Now, so it begs the question, is this project highly sustainable? Is the tightly insulated structure really a sustainable process? And I would argue not, right? And I think about like why, how ubiquitous these materials are. I mean, this is the project that certainly was front and center in my mind during my education, is like, this is what architecture can be. Here, my hero in his hand holding blue foam is not only the material that could, clad a building, but literally the material we're conceiving our architecture of, right? Then you turn to you turn into practice, and you're like, how do I actually put buildings together? Well, you've got this trusty little guide put out by our government. This is how you build housing in Canada. And you go to the back and you pull apart, there's 77 layers in your typical Canadian house, and 11 of them are made of petrochemicals. That's a very high proportion of our construction fabric derived completely from a family of materials we all know we need to distance ourselves from. The environmental impact of these materials, here is the things we insulate our buildings with, EPS, rock wool, phenolic foam. Here's all the other things that, foam and insulations do other than, keep your building warm. They lead to climate change. They lead to things I don't even quite understand, like terrestrial eutrophication. None of these are good. This is the provenance of our insulation. And the killer is, we know there's alternatives. We know there's better things out there, like wood fiberboard, where, products you'd have to import from Germany or Austria right now if you wanted to use them in Canada. But like Canada importing something made out of wood, it's just preposterous. But these things are out there, and it's up to us as architects to know about them and to ask for them. So we've been thinking about, okay, what is the new language? What is the kind of framework to build this around? And where does architecture go from here? So I'm going to speak to these three things: a kind of lexicon, a return to passive systems, and a return to, I would say, material regionalism. So first, taking good, clean, and fair is from the food movement. Thinking about what's happened in again in that industry over the last 10 years in food. How does that relate to buildings? So good. We believe everyone deserves good design. Good design is beautiful and just. It's essential, delivering human rights, essential services, and spaces that will build for a better world. Design should be a fundamental right. Clean, being clean is being climate positive is imperative at this point. Our projects strive not only for efficient operation, but for the design of the entire supply chain to be resilient, restorative, regenerative, and finally, fair. Looking at the design and construction process holistically, from the points of extraction to assembly to operation, ensures that we can have safe, equitable labor practices, in construction and in the maintenance and utility of the building. So the first part of this is really, I think, that the big pink part of the pie, and it's really a thinking about how we return to passive systems in our building. How do we detach ourselves from 100 years of mechanical engineering? Where this pie is distributed, really, if you look at this, is like there's direct on-site emissions. There's the things I'll speak to in terms of your house right now. The gas-fired boiler, if your furnace, you've got a gas stove or oven, sorry. You've got your air conditioner out back that's leaking. These are where your emissions are as a homeowner, right? Or a building owner. This is the direct on-site emissions that you control right now. And then there's the things that are out of your control, the indirect emissions, like where your electricity comes from. And if you're in Manitoba right now, you can feel good about yourself. We got an incredibly clean grid, at quite the environmental cost, mind you, but compared to other provinces, as you'll see, electricity is not a big burden as it is in certainly other parts of the world. And then there's the gas leakage. All of the piping required to get that natural gas to your house is like an enormous problem of where emissions currently lie. Moving to, when I moved to Rwanda about 7 years ago, one thing that struck me right away was this kind of image on this right, which is kind of stand-in for any building in the tropics around the world right now. This air conditionerification of architecture. And these air conditioners are really a symptom of really bad design. This building was not designed to actually breathe for itself. So it needed these machines to be strapped to it to breathe, literally buildings on respirators. And in contrast, the kind of research happening at the AA, not 50 years ago, focused on like how does tropical architecture that can live and breathe for itself. And really what you see here is a great forgetting. Like we have this knowledge, it's there, it's in our libraries, and yet we're not using it. It's begging to be resurrected. If you've ever read Project Drawdown, these are where the leading causes of climate change are, and where if we spend some energy, would address it. I'd really encourage you to get the book, and I've highlighted the things that are in buildings here. And what's interesting here is a lot of the conversation, even Bill Gates' most recent book around alternative cement, you can see is like number 32, as far as like where emission change could happen, high performance glass at 27. Go at the top there, refrigerant management and alternative refrigerants. That is like number 4 and number 7. And refrigerants are those nasty little things we use in our air conditioning systems. And this is where we need to be paying attention. This is why we need to get our buildings off air conditioning, right? So every refrigerator and air conditioner contains these refrigerants that absorb, release heat, enabling chilling, CFCs, HCFCs, acronyms that you've probably heard that you know are not good for you. And they can be 1,000 to 9,000 times more harmful for the atmosphere given their chemical composition. And yet these things are leaking every day because we're cooling our buildings. Now, when we started, this is the Butaro Hospital, first project in Mass Design Group. We arrived at a part of the country at that point that had no doctors, had no power. And the kind of first thing was like, well, if you're going to design a building that might not have electricity, it's a kind of great liberator, in fact, because you can't rely on mechanical systems. You have to return to first principles of design. And this became newsworthy. The front page of the New York Times, soon after being completed here, that a building's natural passive ventilation is newsworthy, right? It's kind of incredible when you reflect on it. And, presenting this project now during the times we currently live in, decisions made then seem kind of, obvious now, like taking the circulation and putting it on the outside, not having corridors embedded in a building, making people feel, they can safely pass each other. Airborne disease is not something that can be easily transmitted. Things that I think now we're beginning to look at our buildings completely differently. Were done here over a decade ago, and to great success. The wards, this is the most sustainable image we've ever produced. This is a ward, and you'll maybe notice there's no mechanical ventilation in the space at all. It relies completely on the buoyancy of the air coming off the patient and the simple fact that the building is designed for cross ventilation. Windows on 2 sides that can open, one slightly higher than the other, oriented towards prevailing winds, and the wall down the middle serving as the utilities, something that could be easily adjusted as medical needs change. On the success of this project, the Ministry of Health said, "This is great. We've got about 29 others we could really use some help with. Can you help us, think about this?" And we designed a set of kind of the DNA of district hospitals to understand patient flows, doctor flows, and what all these sites needed to encompass. And because their procurement team, the people that are actually going to solicit the RFPs and oversee the work, we wanted to give them also tools to evaluate, proposals that they come in, but also publish so that other engineers and architects could take them and orient it to their own practice. Simple things like, where's the sun? How do you orient your building? Where's the wind? First principles. Again, Leon Fedney is kind of chiming in my head here today. And when it came to the buildings and looking at how, again, to get air changes in the room, the human body is a natural radiator. And this, working with Mazzetti, looking at how to tune the facades, if you could, the amount of opening you have low and high on a wall, to create a kind of natural flow through of the space. So in the event that there isn't electricity, here we've got low velocity fans, that the building will maintain a certain amount of ventilation regardless of whether or not there's power. They then asked us to design 2 projects based on these, and the first hospital I had the fortune of being a part of here, Unini District Hospital. It's this photo from, I think, earlier this week. That's going to be complete this year to kind of test drive this and see what it looks like. So here you can get a sense of what the building begins to look like. And this is near Genge District Hospital in Kigali, which actually just opened a couple of weeks ago. So taking this idea and bringing it to life is incredibly rewarding, and eager to see these in the flesh. We're then asked to go to a really different climate. And Rwanda is at 3,500 feet, temperate. You should go. It's beautiful. Perfect, like 27 degrees year round. Liberia at sea level, hot, humid, lots of rain, and the site's a wetland. So really different climate conditions, and thinking about, okay, how do we still achieve the same ambitions in a different setting? And here, again, first principles, where's the wind come from? How do you orient building? How does heating happen? What's thermal comfort? Just thinking about the range that we can adjust for, and humidity, and how to create cooling naturally. And so, working with folks like TransSolar, we came up with solar chimneys as the right solution to this, where the roof can kind of heat the space up and create the suction out of the rooms, and the chimneys become the architecture, like literally, the building's function becomes totemic of this is a hospital. It breathes for itself, right? I think, and this can be beautiful, right? So the last project I'll show you is one that's currently in construction. It's for Norquin Foundation in Kigali, Rwanda, where we're pushing this even further in the space of co-working space, in office space. And here, again, looking at thermal comfort, kind of like comfort is not a degree, it's a range. And I'm wearing a hoodie for that reason right now. We need to be thinking that we can be uncomfortable. We need to dress up and down where we are in our buildings. So we begin to simple things like optimizing, how do we get the right, R value in the buildings, and what materials are we using for cladding, thermal effectiveness of that. Looking at the diurnal sways throughout the year, hot, but when it's a dry season, wet season, really beginning to think about, okay, what ranges are we working through? When are people in the building? And kind of interesting. I remember, I'm going to bring this back to Winnipeg, but we developed a cooling system that uses a labyrinth in the basement here, and that the entire basement becomes a kind of big cooling radiator. And I remember at some point, I can't remember who taught me, the Walker Theater, its air conditioning was a bunch of ice underneath all the seats that would emanate up. So same principles here, things we did 100 years ago back into our buildings as low tech ways of dealing with comfort. And the building itself beginning to really think about, okay, you can see here the foundations are actually a performative part of the building. It's not just holding it up. Now, the second thing is really more into material provenance and regionalism. And thinking about the two things we use disproportionately is concrete and steel, reinforced concrete, steel in the form of rebar and structure. And you'll see here as like countries, they would eclipse, I think concrete on its own is the third largest emitter if it was a nation here. And a big part of this is how we've been trained to practice. And I look at Jay and his background right now, and I see it right behind him. So I think we can all reflect on this, and you're going to see a bit more about it. Now, to think about why and how we use materials, I'm going to refer to Geddes' Valley section here. The idea that the city's relationship to the wider region and landscape around it was inextricable, right? Added to this Ed Mazaria, who's the founder of Architecture 2030 a year ago, spoke about emissions in kind of the opposite sense, that in your average North American city, 50% of the emissions are in the downtown CBD, and the other 50 are on the kind of carpet of suburban sprawl. So these mountains and carpets. And what I'm arguing for here is that if we're really going to get to net zero, as architects, as landscape architects, planners, all disciplines in the built environment, we need to begin to see buildings and everything that are together, right? That the only way we can reduce the emissions of our cities is by really looking at the life cycle, which I'm going to focus my conversation on. The second is looking at the kind of peri-urban, the suburban sprawl of Winnipeg. Where's all the space that exists, and how can we organize it around this challenge? And finally, on the land use, the valleys, the peripheral lands, the landscape that surround our city. How can we engage them and find ways to actually make them net carbon sinks? That has to do with how we eat, clearly, but I think has a lot to do also with how we source our buildings. So these lessons were learned in the middle of Congo, which is the most remote, most difficult place I've ever been to, far harder than getting to Inuvik. This built in the middle of the jungle, it's the most constrained project site we've ever encountered. To get there, you had to travel down a path as narrow as your shoulders in parts on the back of a motorcycle. So fantastic, design brief. To begin to think about how we need to make it, clearly it had to fit on the back of a motorcycle. So we brought in things like fasteners and tools, but all of the other materials had to come from the project site. We used, you can see here, wood shingles for the roof, mud blocks for the foundations, and had to bring in like bags of cement arduously to use for mortar and some of the binding. Now, out of it, you can see here, the wood shingle was a decision made because, you know, if they needed to replace the roof, you can't rely on it, you know, taking up to a month or more to come up the river from Kinshasa. We wanted to make sure that people could do it right there, should the roof leak. So found a species of tree quite like cedar, froed the shingles, and this roof can kind of live on, you know. The next out of that was, you know, making those decisions where the project was sourced within 10 kilometers of the site. Economically, this is an absolute windfall here, you know, in a country that, you know, historically most all the finance, you know, makes its way to Kinshasa. Here, the bulk of the project's budget made its way immediately into the town and the surrounding area. And for a month, this is the first time we looked at embodied carbon too. We're really curious to know, how did this project stack up? And it's embarrassing, like how good it is, relatively speaking. So, you know, it's kind of also no surprise. You're building out of things that are sourced within 10 kilometers of the site. You're using wood, you're using earth construction. So this is what, you know, buildings can look like, you know, an architecture of the earth and not something put onto it. Now, out of this, we began working with MIT and a few people to think, how are we doing across the board? How are our projects as a whole doing? Where can we improve, and what have we done well? You know, and happy to say we're doing a lot better than the global average, but, you know, beginning to say, okay, these are the choices we made there. How can we improve upon them on the next project? And, you know, this project I was involved with, the University of Global Health Equity, slightly below the global average, very conventional construction, concrete block. You know, we can do better, obviously. You know, looking at Butaro 10 years ago, we're like, wow, this project's half of the global average. This is hitting the 2030 targets, and it was built in 2010, way ahead of its time. And beginning to think about why, like what were the decisions we made then that improved it? And one was, well, you know, the story of this project has been this volcanic wall and the makers of it. And like automatically there's a connection here, carbon footprint, human handprint are inextricably linked here. Like this is the solution to the problem. It is how we work with the materials around us and the people around us and finding innovative ways of using them. And I was saying, you know, earlier, I live around the corner from William Morris, and, you know, what he was thinking about, you know, 150 years ago is not all that different than, you know, Anne-Marie's own reflections on her experience on this project. That, you know, somehow we need to bring the question of labor and how we make things and the people making it front and center to this question of climate and pair them up. And the project I'm going to kind of focus then for the rest is one that we've been engaged in now for the last 3 years, the Rwandan Institute of Conservation Agriculture, which opened last year and has a second phase completing this year, where this idea around climate positivity has been front and center from the beginning. So, you know, when we started to think, this is an agricultural school, you know, we can harvest this building of the place, we can harvest it from the earth. We have a really generous site of 1,200 hectares. What's on it? How do we do the most earth-based project possible? And so simple decisions like coffee husk-fired ceramic tile roofing, that's a good way to reduce the carbon in firing. Wood frame structures from Canada, you know, we should use wood, and we're trying to push wood construction in East Africa, where historically it hasn't really been mainstream. Non-fired earth-based walling, so instead of fired brick for the walls or CMUs or anything like that, we're doing rammed earth, compressed earth blocks. And finally, the thing I get most excited about, you can't see in the photo, is the stone foundations. So the mistake I made at the cottage earlier, we did not repeat here. And going to something as simple as a stone foundation in a seismic zone had profound impacts. As you'll see. So how do we do this? Well, we're blessed with incredibly talented engineers that we work with on our team here. You can see Harriet and Amiable, you know, digging a series of test pits around the site, finding the right, you know, mix in the soil triangle here for our blocks, and banging out a number of tests to take to the lab to really fine tune the mix. You know, we went out to, you know, forestry companies in Uganda, Rwanda, Tanzania, South Africa, to find the right, like basically find a sustainable source of wood that we could use and figure out how to work within the dimensions and the drying constraints of them and design around what's supplied and not the other way around. We're also working in a part of the world where there's no EPDs, these environmental product declarations. This is the manufacturer information that would be given to you to say, oh, I want to calculate our embodied carbon. Well, we're not working where there are any. We're in these gray places typically. So we went out and started working with the big brick manufacturer to develop the first EPD, in the country to get us a sense of we want to do our own accounting. And then we did our own accounting. So some of the people I think are on the call here, put together these incredible spreadsheets to say, here's this wall type, here's everything in it, here's its weight, and this is where we sit. And this is why we have a lot of confidence around the numbers, and I can sit here and talk about it in front of you. And here are the results. So on the left, the kind of status quo building you would have seen anywhere for this kind of structural span that we have for this project. And on the right, the difference here and the key things you can see is like the foundation's a third. There's the stone. That's the difference between concrete and stone in this project right there. The roof structure, steel to wood, simple things. And you can see here a 58% reduction in status quo to the design. To get there, this also resulted, like Alima, 96% of their materials were excavated, harvested, or sourced in Rwanda. Rwanda, a landlocked country the size of the Netherlands, right? So if it's possible there, it's possible in like southern Manitoba, I would say. Kind of an Eamesian view of this. So at a mile, got things like some of the soil and earth that you saw for the rammed earth. At 10 miles, the sand, the stone, the aggregate, the big heavy stuff that gets lugged back and forth. At 100 miles within the confines of the country, largely, timber, sand, cement, the bulk of the other finishing stuff here. At a regional scale, the stuff that's not manufactured in the country, like wiring and fixtures, things of that nature, we had to reach out to suppliers in Kenya and Tanzania. And then finally, at the global scale, it's like the specialty stuff, the solar plant, the water treatment plant, having to go to China, South Africa, or into the Middle East to find these things, right? So as a whole, the weight of the project is really of the place. And from a labor perspective, obviously, it's also of the place. The 98% of all labor associated with this project is within 100 miles of this project. We, working with our contractors, tried to figure out how do we hire the people of this district. So we kind of tapped out at one point. We hired every able-bodied wanting person looking for work at a certain point. We had 1,000+ people working on the job site at any one time. And then we took the opportunity to do the interiors and really push things of the finishing on the inside. So here we found Walaris, is the godfather of Rwandan ceramics, to do the tiles for the wet surfaces of the project. We worked with weaving cooperatives here, sisal co-ops here, to weave kind of light fixtures that you can see here on the right of the faculty housing. We started our own furniture making company to kind of fill the hole of woodworking and industrial designers to work with them to design all the furniture throughout the entire university here. Here, Banana Weavers Co-op that we contracted through to do the seat backs and the surrounds for the couches and some of the residential furniture here. Again, using an agricultural byproduct for an industrial product. And how this adds up, we've been thinking currently working through with Atelier 10 and our team, say, okay, what does it actually mean to be climate positive or net zero, and how do we get there? So it's really a kind of accounting here. You can see on the left of, the buildings of a certain footprint, the infrastructure, the roads, utilities, the water plant, these all have a footprint. The solar plant has a big footprint. The landscape has a footprint. These kind of like add up as like, okay, on one side of the ledger, this is the weight of this project from an emissions perspective. And we've been thinking about, okay, we have a big site. How could we plant and what do we plant? What species could we offset this? And how much space do we need to do this in? And so we figured by planting 60 hectares on the site with a range of species, over time, in the next 11 years, we can offset the project on site. It's not offsetting, it's insetting, right? This project can be a net climate positive project, by 2031, by just planting 60 hectares, right? And two things out of this. One, the pink bars could have been a lot taller, as you've seen. They could have been twice as tall. So that's a good place to start from. 2, the thing's entirely off grid. So the operational carbon is pretty much a write-off. And 3, we're blessed with a lot of land area to do this. But I would argue that this is the kind of approach we need to be taking, and where architects and landscape architects and planners can be working together to bring this approach to any project. Now, the kind of question I get at this point, so I don't know why this is low res here, but great, you can do this in Rwanda, but how do you do it in Winnipeg? And I think it's an important question to ask, because Rwanda, they're over on the right side of this graph, right? Like they're proportionately not they're doing okay from an emissions perspective. I was really interested in answering this question in Canada, because Canada we do not do well. It's abysmal how bad we are from a carbon footprint perspective. Like slightly better than Saudi Arabia is not good company. And I would say that, the imperative is on us to really make big changes in how we're building and how we're living, to do our part, to make this planet livable. So over the last couple months, I've been teaching a research studio at the University of Toronto to ask this question, how do we have the emissions of construction in Canada this decade? And that you can see there's the Instagram handle to it. And I'll bring up the second part of this presentation. So I'm going to try to keep this to 20 minutes. So to do this, was fortunate to have 10 firms in Toronto partner with us, and wanted to focus on multi-residential housing, because it represents the most square meters happening in the GTHA in the Greater Toronto Hamilton area, a range of scales, so townhouses up to high rises, and all projects that are recently built or in construction, to answer this question, from 10 practices across Toronto. It was great. Like the interviewing of them to understand, what was driving the decision making, what's the kind of project pro forma, why these materials, why the structural system, why'd you design what you designed, and interviewing the practitioners was really revealing about the kind of why things like zoning became front and center. Like, well, I'm just responding to zoning, right? What I'm allowed to do, this kind of as of right condition. We took the projects, the students then modeled each one of them, developed a sectional model, and we put them through this one-click LCA, which is a program that aggregates basically EPDs and quantities and gives you the footprint of the building. Out of it, you get this kind of information. This is my cottage, so it basically gives you a graphic sense of where emissions sit, how you can improve upon them. Here again, probably wouldn't insulate it the way I did. What the calculations include structure, envelope, interiors. It did not include all this other stuff. It does not include MEP systems, does not include excavation, which I'd love to talk about. It's imperfect math, but I'd say it probably is. It's about 80 to 90% of the equation. A building structure is really the meat of the equation, and the results are here. So this will be published in Canadian Architect in a week or two. But basically, you can see, like, if I said to you, hey, you have to have the carbon footprint of every square meter built, to be like, well, the first thing you could do is like just don't go tall, or don't use as much, don't use concrete, use wood frame. That's the kind of quick takeaways with today's technology here. But it's interesting, low rise is roughly about 250 a meter, and the mid and high rise didn't differentiate that much because it was all made from cast in place concrete. Now, the key findings, which, some analysis out of this, the students just didn't do the numbers, but like, why is it the way it is? And there are 5 key things that I've sent in an open letter. Again, hopefully you'll read in next week after this. But, the one is just our addiction to concrete. Again, Jay's background here, but cast in place concrete is the largest driver of emissions across all of the projects. It's the low-rise projects employ wood frame structures, have concrete foundations, that are roughly half or greater of the footprint of those projects. And then on the flip side, the lowest carbon mid-rise project had steel hollow core instead of cast in place, which is kind of intuitive when you think about it. So simple recommendation, incentivize lower carbon structural systems. And that's, I think, just set a target and make people come down to it. Here's what the projects look like in kind of pie chart form. When the thing that I hope sticks out is like all that red. That red is the concrete. You can see proportionately, the radius is proportionate to the project's footprint, and then it broken up by material class. And the second here is aluminium or aluminum, as we would say, and that relates to envelopes. And so, say driver one is all structural engineers, really. I think we're in charge of grids and telling them like where we don't want columns, or we do want them, and we should probably ask for more columns, I would say. But the second is envelope. This is entirely our purview as architects. So carbon intensive envelope systems, so XPS insulation, and aluminum extrusion-based glazing systems, which is a polite way of saying window walls, which is a Toronto invention, believe it or not, carry the highest embodied global warming potential of all materials in the study. So XPS insulation is extremely high, attributed to the blowing agents, and aluminum sourcing and smelting, energy intensive, as you can imagine. So pretty simple recommendation, incentivize the development of lower carbon envelopes, and follow the AIA's large firm roundtable advice, avoid foam, especially SBS, something put out over a year ago that I'm still waiting for a Canadian equivalent to state. So here's what our wall systems look like when you put carbon on top of them. I think this is probably the kind of drawing we should have in all of our construction documents, but you can see this tells you where carbon lies. And the one on the left is actually not one of the projects. The one on the left was done by a student, which I'll show you in a second, where she replaced XPS with wood fiber board. But the things that stick out is, insulation is, proportionately high. And also these window wall systems on the right have got horrible R values, but they're also both horrible, really bad from a carbon perspective. So the next time you see a rendering of a high rise in Toronto, just look at it through the lens of like, wow, that's an irresponsible decision. This is the two installations next to each other. So, our good friend, the Pink Panther on the left and this German product on the right, and like the order of magnitude difference between the two of them, like it traps the same amount of heat. So it's a simple question of specifying. The third, and this is where planners can get involved, and I think planning policy and how we think about constructing our cities, big part of it. And this is on-site parking and subgrade floor area. So foundation works, parking structures, below grade floor area are disproportionately impactful. So mid-rise and high-rise structures, you'll see up to 50% is related to all of the work below grade. And the exception to this is the one project that can't go below grade because it was in a flood zone in Toronto. And my recommendations here are twofold. Like one, reduce your site parking requirements. And also the bigger one is actually all floor area should be counted as floor area, which I would love to talk about, Jay. So here is, the low-rise projects. You can see like these projects that are just like a little, half foundation. That's where all of the footprint is, just the concrete to keep the building out of the ground. And then you get into the mid-rise, and there's a Titanic on the left there, the Duke project. 50% is due to the below-grade foundations because it was built, what had been a water course. So it's kind of this bathtub of a project just to allow people to park their cars underground, which is nuts the more you think about it. We're doing all this work to go down only to park cars down there because we have to, right? So one student said, well, you want to meet the 2030 targets? That's easy, just get rid of underground parking, and she's dead right? It's so simple. The fourth is kind of knock-on effect to this is the spacing requirements of parking. So, the parking's, our cars and our kitchens are not the same, right? And it's that gymnastics that happens to mediate between the two results in some really big transfer slabs. So this is one project downtown where the entire ground floor is a meter thick slab of concrete to mediate between the parking structure, the 2 floors of parking below and the 11 floors of housing above. Really simple, but like just profoundly dumb. You think about it, like what we're doing here. And this other project, the 13th floor, has a 2.8 meter thick slab of concrete to mediate between these two grids. When we first saw the drawing, we thought it was a kind of error in the drawing set. There's just a poche the entire floor. It's like a Noli plan on steroids happening on the 13th floor here. And the fifth is a step backs and transfer beams. So this is a little more in the weeds here, but it's the angular plane of like wanting to get, make sure that you're not casting a shadow on the street, but what it results in is a lot of kind of structural gymnastics, which again adds to the carbon of a project. Now I'll show a couple projects in 10 minutes to make sure we have enough Q&A here. So Core Modern by Bate Sorba, Is a really beautiful contemporary step town here in Toronto. If you haven't seen it before, it's been pretty widely published. And so the methodology was similar to my cottage. Take a section that can tell you part whole, enough to tell you the rest of it. So this is what, this is what residential construction looks like. It's a lot of stuff, right? And was interesting to see a kind of really even distribution of emissions on this project. The student broke it down. It's like these where the material volume is in the middle and their proportionate emissions are on the right. And as you go through, it's kind of interesting. This is all the structural wood related to it. Here's my good friend XPS in the middle. You can see small, big on the right, and all the insulation classes. Drywall, another material I would say we've been indoctrinated to use, like it's, I don't know why we use so much bloody drywall, but we could be doing a lot better. Somebody needs to invent a replacement for drywall because it's got a very high footprint. And brick in this project. And so brick actually is kind of one of the things about that made this unique. And so the student wanted to get into a little bit. The brick did not come from Toronto. The architects wanted a kind of gray brick. So they sourced it from Nebraska and from Arkansas to get these two shades, because the Toronto brick is a bit redder, oranger, the clay body there. So, similar to the oat milk, the transportation part of this wasn't much of the footprint, but what is where things were made. And this is why it's really important to think about what you're asking for, because the grids that Arkansas and Nebraska sit on are not your Manitoba grid. The power that's firing the bricks in these states is, partially or all coal-fired, not electrified like Ontario would have been. So it's really important to think about where the thing is coming from and the grid it sits upon. So that's why these two bricks are much higher. Had it been an Ontario brick, it wouldn't have figured so highly. And this is why it's important. So here's Canada's grid share. You can feel really good about yourself in Winnipeg right now. But I think that there's a flip side to this. Is like, if your electricity is clean, the argument for, say, passive house standards is also way harder to make, because why pour a bunch of money into high emissive insulations if your power base is so clean? The argument for kind of retrofitting your house in Alberta, that's front and center. You can see Alberta's got a really dirty grid, same as Saskatchewan. I don't necessarily see it that way for, say, British Columbia or Manitoba. And that's why I think we need to begin to see these things holistically and not just think there's a solution for everybody, because your grid really matters. He got into spray foam too. So this one's a little fun. Really just like, what is spray foam is a good question, and began to look at the specification, the EPD. These are documents that you can download, and like, what's in it. It's kind of this is the nutritional facts label on the back of your cereal box here. This is what spray foam is. It's a two-part thing. There's a foaming agent, there's a blowing agent that come on site, and there's 24 things that happen to till this thing gets stuck into your wall, right? What's interesting is a lot of the legislation, the Montreal Protocol, that governs the use of chlorofluorohydrocarbons, the things that are in our insulation, the blowing agents that I mentioned, are kind of baked into this. There's a legislative framework behind this that we're somehow related to. And he got 3 EPDs and wanted to compare them. Which was really interesting is that the Canadian-American one was like a quarter of the European one, which is really counterintuitive to your you would assume the European would have been a lot better. And it's like, that's curious. And so getting more into it, D, this is the end life cycle, the disposal stage, claimed to be these negative numbers mean it's actually sequestering carbon. That like spray foam, don't worry, when you throw it out, it's actually a sink, a carbon sink, right? That's what this math is actually telling you. It's like, that's funny, So he went and looked it up. He looked over it. Oh, it's citing this paper by Chelson and Jensen in 2001. He went to the paper and found that, well, this is really dubious. Only 50% of the CSC content were released between 9 to 300 years. So the manufacturer is taking this incredibly vague time frame and say, don't worry, it's a negative. They're taking the 300-year part of that equation, not the 9-year part of the equation. They're cooking the books in what they're telling us, right? So, and I think a more simple way of portraying this choice is like, here's 2 images. What side of it do you want to be on? And I would say that if we need to take the lengths that this person is taking to apply this material, we probably should not be specifying it. I think I'm kind of at time. I wanted to show, I'm going to leave it there to open up to Q&A, Jay. I could go on a bit longer, but I want to leave it there.
All right. If you'd like, you can cover this one too if you want. But you want to go?
I've got one other. Actually, yeah, I want to talk about this one.
Yeah.
Sorry. Yeah. I'll do this one because it gets.
And then, in the meantime, if you have any questions for Kelly, put it on the chat and we'll just go over them. I think there's a lot of questions already coming up. So let's just go over this one and then we'll take the questions. Yeah.
I'm going to be as provocative as I can here, and this will get to the heart of the matter. Any good Canadian and our fundamental right to have a basement. So I will hopefully we'll leave it with this. The Levitt Goodman project is Alexander Park is in Toronto, which essentially it's a mid-century social housing project that's been redeveloped and intensified. And so the residents that were there were basically asked, hey, we'll move, you could be a new unit to kind of free up the land, and the city owns the land, the TCHC is the developer of it. So real interesting project, and you can see the SQ1 is actually in the back of this photos. They're both projects that are in this. So both kind of Toronto Community Housing Corporation, community housing, projects, kind of lower end from a cost perspective, and really interesting to get into. Lower cost projects have higher carbon footprints, it turns out. And part of this, in the interview stage was like, normally we wouldn't have basements, we'd just do slab on grade. But the residents were like, our occupation, our going along in this project, if you don't give us a basement, we are not going along with you, right? Like, it's fundamental. There was like, as I said, like the right to have a basement is like in the Charter of Rights and Freedoms in Canada, seemingly. And it's funny when you think about it, like, this is what a basement looks like. This is the basement I grew up in, playing video games down there. My mom's on the call, she should probably go on about it, but like, this is where Sidney Crosby shoots pucks against laundry machines. Like, this is our culture on the left. And then, as you make your way up the food chain, your basement begins to look like the thing on the right here. But if you look at the image, it's just concrete, right? It's all concrete. So now that if you've heard me talk for an hour, you can kind of begin to sense of like, what's that? So I asked the student, okay, what are the options? Like, what if they had done a slab on grade? What if, basement floor area was floor area, right? What are the differences here? So just a kind of different equivalent floor area, GWP, 30 kilograms a square meter down to 21 for the same space, so that's a third, that's good. And I got really radical and I said, what if you do it out of stone, right? What if we go back to how we used to do foundations, like the foundations of a house in Wolseley that I once replaced and jacked up on a Severson-Montaigne project back in the day, I think. This was the foundation of much of anything we built up until the 20s, 30s, 40s, probably. This project on the right? Why are we not building with it? This is the difference in stone and concrete. Concrete left, stone on the right. And I will leave it with that slide.
Wow, thank you, Kelly. That's lots to cover here or follow. I guess we can start taking some questions, but as a starter though, what's your sort of opinion or suggestion moving this into every building? Sort of, I mean, you made 5 points, which is a good start, right? And then I think the objective, as we think about these things, we want to do this as a kind of, and it seems like Mass Group has built this psyche into everything they do. Like in terms, I mean, you didn't really prepare those sheets for the presentation only; they just do it, right? So that's, I mean, that's part of it. But what are the key things that you think that we should think about when we're trying to push this to every building? Are you in that perspective, those 5 points are the starting point, you think, or is there something that you would sort of think about?
Yeah, I mean, I think the first two are, doesn't matter on your typology or your geography. I think first two are front and center. The first thing is basic literacy just around this. I think personally, only began to think about this a couple of years ago, and I've been working to try to familiarize myself with what it is, how to talk about it, just teaching myself, right? And I think the first thing for all of us that anybody's willing to listen to me for an hour, is our basic literacy around this issue and how, you know, as I said, this is the part that we own. This is where our agency is. We specify materials, right? We can't tell people how to use their building. We can help them, but that's after that, it's up to them. So this is really where our responsibility lies. And so I think the first thing is like becoming familiar with it, becoming literate in it, familiarize yourself with the really easy tools, and beginning to ask questions when you specify things. I think the biggest lesson I had, you know, joining MASA and moving to Rwanda was going to a context where there's no product catalogs. You know, like the first time I drew a window and the guy's like, well, what do you want me to make it out of? You know, and it led to a whole bunch of questions I never thought to ask about, you know, the window, like why the glass that big and what that means and so on and so forth. And I've actually been working with John Sawatsky, who you might remember at Lowen Windows. We've had some back and forth because I had Lowen Windows for my cottage, and I actually wanted to know more about the windows. And it's been really interesting because, like, well, this glass comes from Fargo, this one comes from Collingwood, this wood comes from BC, this one comes from Oregon. And you begin to understand the composition of even, you know, the Lowen window that I've grown up thinking is a really good product, and it is really differently, and even how you might specify the window in your project. And it just asks, I think it just begins to with having asked the question of where does that come from, the same way we've been asking that about our food. And then from there, once you go down that rabbit hole, you're never coming out. I mean, I can tell you. So join me in that rabbit hole. And then things like your structure come, you know, will hit you in the face. And then like doing a concrete basement is like, at this point, I would say is irresponsible. That's my, I speak for myself. I think, you know, we need to find other ways to found our buildings. I think the way we clad our buildings and insulate them, we need to be thinking about it. Like you've seen my rail on XPS, and I think it's just a matter of us asking for something different, you know, and it's our ability collectively to move that market. To say, well, we can't do it, they can have it in Europe, but in Canada, we don't have it. Well, if we all ask for it, we'd have it.
Yeah, so I want to talk a little bit about FAR, but before we do that, maybe we'll take some questions from the chat box here. I mean, we can start with the easy one here up there. The very first one: would the half studio be available next year?
I hope so. I'm hoping to do it again at UT. Yeah, we'll see. But I'd also be totally open to do a workshop or anything. Anytime you guys at Manitoba want to do something, please call me. I would.
Great. We'll follow up on that for sure, yeah. Kelly. So the chat box, the recent question from Conrad. Would you like to turn your video on and ask yourself this question?
Sure. Yeah. Thank you for the presentation. I missed part of it, but I've been following the Towards Half Studio on your Instagram quite regularly, and it's great work. Yeah, I just wanted to ask about the Toronto Green Standards, having worked with them a bit and also seeing how they're kind of developing.
Yeah.
I have a gut feeling that, again, they really value operational energy reductions. You know, the triple glazed aluminum window, is it really so good, taking into account its embodied energy? So I'm wondering if you have some opinions and some views on the TGS and what
Sure.
that's doing.
Yeah, I mean, so I sent them an email. I sent them these results in December, and we just co-wrote a grant application for the Toronto Atmospheric Fund that will hopefully lead to a benchmarking study for Toronto on the back of some of this work to set benchmarks. And I missed the slide. I don't know why it came up, but the whole studio was inspired by Vancouver. And if you're not familiar with what the city of Vancouver is doing, first city in the world to have embodied carbon targets, you know, and they basically did this. 2018, they went out, they did a study of 40 buildings, and they said, this is what we're doing in 2018. Okay, you want to be in business, you got to be 40% less. Really easy, will lead to innovation, going to change the game. And I think it's basically what I'm calling for is every university in Canada should do this. What's Winnipeg do right now? Great, 2025, let's get 40% less, right? Every architect is going to be like, wow, great. Okay, well, how do I innovate? Same with structural engineers. Planning office would be like, okay, what are we going to do? Change parking requirements. And so I'm working with the TGAS team to get this into the next version. Because the answer isn't to say like triple glazed aluminum wall is bad. The answer is like, how is it all together? Like what's the actual, per that kind of slide where I showed the project getting to zero, you need to understand the project's upfront, embodied, you need offset, you need to see a kind of holistic view of the project, say, this is our plan to get to zero, and operations are a part of it, but so is everything else. And that's really, I think, where we need to move. Hopefully that answers your question, Conrad, but yeah.
We'll take another one. Melissa McAllister, are you still there?
Yep, I'm still here.
Perfect. Yeah,
hey, Kelly.
How are you?
Good, how are you? Good to see you.
A long time.
Yeah. Yeah, I guess my question, obviously we're at Prairie Architects are always trying to convince our clients to not rely so much on our electrical power grid and look at other forms of energy. So for us, it's usually about payback, like because energy is so cheap, the capital costs take so long in payback years for clients to see sort of the value come back to them. But how would you sort of try to convince maybe a Manitoba client to go elsewhere?
So like what other forms of energy are you talking about? Like on-site generation?
Yep, on-site, solar, wind.
Yeah, well, wind might, even with solar, so I'll speak to solar because I think, this RECA project's been interesting. It's the entire project's based on a solar grid, second largest solar grid in the country, just for the project. And it'll take 16 years of generation to offset itself, right? So all of the aluminum frames, the tracking, the batteries, the photovoltaics, all of it, comes at a big cost. So after 16 years, we're going to be positive, right? It's a 20-year warranty, by the way. So I think this is the kind of important thing about thinking about renewables and where we're getting our power. That part of the equation needs to be in it. Like that's a decision, but it feeds back into embodied and what is the operational assumption? So again, what's the grid? I think an argument for power in Manitoba, sure, if we're selling it on to North Dakota to help the grid, and all the chain down south of us get cleaner, then the imperative is on us. And I think there's easier ways to reduce that in Manitoba. And that's like build less floor area, live in a smaller house, use less energy. These are all things that we could be doing as opposed to like adding bells and whistles to our projects. Like convince your client that they don't need a basement. You'll be like saving way more. You'd be doing a lot more for planet Earth by convincing them that than you'd be by adding something onto the side of your building.
That's great. Thanks.
And I know that's like a hard sell, but honestly, that's the kind of change. If we're serious, if we actually want to survive on this planet, that's the change we need to make.
Yeah.
We're not going to renewable ourselves out of this hole we've dug. Like that's just making a bigger hole.
And that's usually where we start first is how can we reduce our use and then go from there.
Totally.
Well, with that note, maybe we can touch on FAR issue a little bit. I mean, you've studied the FAR research, particularly to housing typology. Mm-hmm. Is that something that you're interested in, aligning those two things together, or is housing typology in particular is in its target typology that you think is going to work quite effectively to this change?
Yeah, we started with residential because, Toronto's. Most cities, the bulk of the housing or bulk of the square meters are being built as housing, right? So wanted to take the battle to that part. Mm-hmm. And then you get into it right away, you just realize it's like Canadian architecture is just like form finding within the confines of our like British like planning apparatus. Like that's what architecture school like ultimately could be about. Here are all the laws we've created to tell you exactly the maximum that you're allowed to do, right? And that is where FAR and all their zoning bylaws sit. And in fact, the zoning of, say, the city of Toronto, I'm sure Winnipeg or any other city, is dictating density in a kind of typical North American density goes here, and then around it is like low density, and that kind of hyper density, low density next to it is carbon intensive. Like you can just see it, like all these high rises out of concrete. Is twice that of a house next to it. And it begs to ask the question, there's another argument for high density low rise or high density mid rise, something we can build out of stick, something we can build out of wood. it requires a completely different planning apparatus. It requires planning students to go out and be like, okay, wait a minute, how do we just completely break the rules? And FAR, so specifically in housing, the fact that subgrade floor area in Canada does not count against your FAR, that's a problem, right? So if you're a developer in Toronto or Winnipeg, what have you, you're like, oh shit, every unit I need a parking space. Well, if I do it above grade, that's bumps up against my maximum height. I'm losing units. I'll go down. Even though going down costs like prohibitive amount of money, like a parking spot is like way more expensive to build than any finished floor area above grade. It's still, you can go to the Earth's mantle under the current zoning apparatus, like unpenalized, but you can't go up another story. And I think this is where we need to begin to have a discussion like, okay, how much parking do you really need? And can we get allowances for if you actually did it above grade? Or, hey, surface parking's not that bad of an idea after all, Winnipeg, or maybe just get rid of it all. Maybe we shouldn't be using cars as much. It's probably the easier discussion to have.
Well, thanks for that. We'll just capture a couple more questions, Kelly, and then maybe we'll start to wrap around after that. One question that I see here is about the stakeholder presentation. Where was it? Malvin, if you're there, could you speak to your question?
Can you hear me?
Yep. Brad.
How's it going, Kelly?
Long time.
Good to see you. I just, I've been following your work for a little while now, and I'm a real admirer of the way Mass Design Group talks about both their practice and their projects through the lens of data, the way you've done this. And I just wondered if you could talk a little bit about whether that was a shift in the practice at a certain point when you were looking at this, the way you talk about what you do, or whether that was kind of like a foundational step in the way Mass thought about architecture.
Great question. So foundational, and we were born out of a healthcare NGO. The first project came out of, we volunteered, we worked with partners in health, and gained their trust. And said, can you help us design this hospital? And I think out of working in that space with doctors who, every year they had to go back to the, Gates Foundation or the Clinton Health Access Initiative to say, here's how your money's being spent. Here are the results. We're improving, child mortality has been improved by this amount, right? They're kind of tracking things. They use statistics to prove like your investment in our organization is, showing results. And I think taking that and like thinking, okay, what is the architectural equivalent of that, right? So from the very beginning, I think that's been in our DNA. It's like every year, what impact are we having? And how do you measure it? And I think this is kind of in all our projects, the first question we ask of it is like, what's the mission of the project? Like, why are we putting a building in this place? Like, to what end? And, one of the next questions is like, how do we measure success? Like, what would be the things that you could, measure as to show that you're actually meeting your objective or not? That kind of comes in a range of things. Again, I think a lot of our healthcare projects look at, the ability for the architecture to help health outcomes. But, arriving at this climate stuff like this, it's all data, and it's really easy too. Like we work in data all the time as architects. I mean, you sit around there and you're specifying this goes up 0.5 or 0.75 and over in that direction. Every time you're drawing a line, you're specifying area and volume. And all of this is doing is taking that math and marrying it up with the footprint associated with that volume. And it gives you a good sense of like, that's my footprint, dead easy. It's so easy. And I would like, if you take one thing away from today is like, go out there and like, take one of these tools. Like there's a couple of open source ones. There's ones that you can buy a license for really cheap. Some of them marry up with Revit. And this should be part of your design, process and early on the game. Because the decision making too, if you do this in concept and schematic, that's where the maximum potential is, like, to drive change. If you're into CDs and doing this, like you're too late. And even better, if we make this law and we lobby our provincial bodies and we lobby the RAC to make this mandatory education, and we lobby the planning authorities, wherever you're practicing, to like get this into targets, it'll begin to really move. And that's what I'm hoping by speaking and sharing this, is like getting people fired up about it, to say, fuck it, we need to like change the rules of the game here if we're going to actually, have a planet for our children to survive on. So that's why I'm on my soapbox, being such an evangelist.
Well,
Fantastic.
thanks for that. That was great. Maybe we'll capture one more here inquiry. Conrad Jabo, are you there?
Yeah, I'm here. Can you hear me?
Yep. Hey, Conrad.
Yeah. Hey, Kelly. Thank you for your presentation. I liked your works in Rwanda. Coming from there, I was wondering, how do you work with the craftsmanship in Rwanda to maintain the quality of the product and the quality of the idea that you have at the beginning?
Work with them. That's kind of it. I think the craftspeople, save for all that furniture for Rika, we're blessed with a really good team on our side too. We got like 10 industrial designers and carpenters who are going out and finding them and working with them and doing prototypes, and okay, this is perfect, do 10 more, here's a contract, and on the construction site, we actually started a construction company because we thought like, hey, we can improve the impact of construction and we can get more women into it and we can make sure the quality of control and safety on the job is high. So we started a construction company, like this, we started a furniture company. But the short answer to the question, Conrad, is just like, work with people, talk to them, and empower them. People are going to deliver quality when they believe in what they're doing. And back to the first project, the Butaro Hospital, the volcanic wall. The story originally, the masons got around to the fourth corner that they'd started on. They're like, oh, we've got a lot better. We want to do it again. And they tore the wall down on their own to rebuild the first stretch where they were just starting. They've gone on now to like start their own cooperative where they're doing this on like around the country for like high-end hotels. And it's like the idea that a detail or a drawing has led to an entire workforce around this it's amazing. And it really begs the question, like what would that be in Winnipeg again? Like, can you imagine? Just look at the legislative building downtown Winnipeg and think about how good the masonry of limestone was 100 years ago. And like, why are we not building with more limestone? Where are the good masons right now? I'd be very curious.
Thank you.
Well, thanks, Kelly. I think there's one more comment here or half question. Jenna, we'll maybe take your comment and we'll try to wrap the discussion around that. Jenna, are you there? Can you?
Hi, yes, sorry, my camera doesn't seem to be working. Hey, Kelly, it's Jenna from Old Mass Work. How's it going? My question was just, I'm curious about the case studies that you guys did at the U of T with these like large commercial firms in Toronto. I'm just curious how many of them were like genuinely interested in these studies and the findings. Having worked with some of these firms, like I just think it's really interesting to be able to bring up these concepts in an academic setting and then tying this back to the industry,
Yeah. Hey, listen, they signed up. I was like, this is what we want to do. I'd love to have you involved. And they're all in, and the interviews were really interesting because some people were like, they're all very disclosive. They were like, I'm not surprised that this is like got a big carbon footprint. Like, this is why, this is the mafia that is concrete in Toronto, for instance. So this is like, this is the system we operate within. And, presenting the work back to them, they were part of all the final reviews. Like the feedback was unanimously like, thank you, this is really informative. And this is going to inform how we think about this moving forward. I've had, done lunch and learns to all the studios, the offices, like students have been giving lunch and learns. I have a student working in she's on this lecture. She's doing work on the side right now, doing calculations for one of the firms. It's like, I think once you know, and I think that, if I have anything to do with it, we're going to change the rules. And if you're a firm not doing this anytime soon, you're going to be out of business. Like this is a matter of human survival and also like the survival, I think, of your business in my mind. So they were all really receptive. They learned a lot from it, and I think, you know, I imagine they're all going to incorporate this in some form of their practice.
Super encouraging. Awesome. Thanks, Kelly.
Yep.
Well, Kelly, thanks for your passionate push on this. I think the biggest thing about this is really, in my mind, as a mobilization that you're causing of all this, because it's a collective effort that we have to take part in. We know it academically, we know it through research, but you're also mobilizing the industry as well as the policy. I think that action that you're taking is quite inspiring. And then thank you for taking time to talk to us today. And we will definitely take you up on that offer of workshop at some point. So we'll reconnect with that issue and discussion. I'm sure the audience here has lots to sift through right now. And then I think definitely it's about step ahead. And we're trying to mobilize all of us towards the near future, I think, towards survival, I guess what you're saying. Yeah. So thanks again. We'll wrap it there and we'll touch base again later. Thanks, Kelly.
I mean, amazing to see so many familiar faces and so happy to be back in Winnipeg, albeit virtually. Please reach out if you've got any questions. I'm here to talk to you.